This is the 7.5 mini lesson on solving inequalities. Aaron wants to buy new football pads that cost $55 at goodsportsbuys.com. The online store charges $11 for shipping on all orders that are less than $75. He's also considering buying ski gloves, but he does not want to pay more than that $11 shipping fee. So he needs to make sure his total bill is less than $75. So it says to write and solve an inequality. Remember, inequality, greater than, less than, greater than or equal, and less than or equal. Write and solve an inequality that describes the possible number of additional dollars Aaron can spend and still remain in the $11 shipping fee category. Let D represent the additional dollars. So here I wrote my inequality. The additional dollars he can spend plus the $55 on the pads has to be less than $75 in order for him to pay the $11 shipping fee. So even though they've talked about $11, that's nowhere part of my inequality. So now it tells me to solve. So if I would take 55 off of each side, the dollars that he has left to spend has to be less than 20. So Aaron can spend less than $20 more. Okay, so to solve an inequality means to determine the value of the variable that makes the inequality true. The objective when solving an inequality is similar to the objective when solving an equation. You want to isolate the variable on one side of the inequality symbol by using operations of adding, subtracting, multiplying, and dividing. So here we want to describe the steps to solve this equation here. Then we want to solve. So I'm describing the steps first. When I see this, I know I need to add 2 to both sides of the equals. So now I'm going to actually start solving it right away too. Second step is going to be to divide both sides of the equals by 3. So now I will do that. And I get x equals 3. So I described it, I solved it, I have my solution. A list of possible solutions for the inequality is shown. So here they give me an inequality and a bunch of possible solutions. Circle the solutions that make the inequality true, then list 3 additional solutions. So I need to substitute here. So if I substitute a -2 here, 3 times -2 is -6. I'm going to make some little notes. -6 minus 2. Add opposite, -8 is not greater than or equal to 7, so this is not a solution. So I could check -1. 3 times -1 is -3 minus 2. Add opposite, is -5 greater than or equal to 7? Not true, this is not a solution. 3 times 0 is 0, minus 2 is -2. -2 is not greater than or equal to 7. That's out. 1. 3 times 1 is 3. 3 minus 2 is 1. 1 is not greater than or equal to 7. 1's out. 2. 3 times 2 is 6. 6 minus 2 is 4. 4 is not greater than or equal to 7. So that's not a solution. 3 times 3 is 9. 9 minus 2 is 7. Is 7 greater than or equal to 7? It's not greater than, but it is equal. So this is a solution. Try 4. 3 times 4 is 12. Minus 2 is 10. 10 is greater than or equal to 7. And we should be able to see that all of these are going to work because in all these cases, when I multiply, I'm just getting a bigger number. When I take 2 away, it's going to always be greater. So if I need to list 3 additional solutions, I might say 8, 9, and 10. Okay, so I'm going to try the same thing here. Negative 2 times 3 is negative 6. First of all, negative's never greater than a positive, so that's out. Negative 1 times 3 is negative 3. 0 times 3 is 0. 0 is not greater than or equal to 9. 1, 3 times 1, 3 is not greater than or equal to 9. 2, 6 is not greater than or equal to. 3 times 3, 9 is 9 greater than or equal to 9? It's equal. 4 is going to be greater, 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 greater. If I need to write 3 additional, 8, 9, and 10 would work here too. Okay, same thing one more time. This will be even easier. Is negative 2 greater than or equal to 3? No. Negative 1's not. 0's not. 1's not. 2's not. 3 is not greater than, but it is equal to 3. So 3 works. 4 is going to be greater. 5's greater. 6 greater. 7 greater. I'm going to add 8, 9, 10. So what do we notice about the solutions we circled in all of those? They were all the same solutions. What do we notice about the 3 additional solutions we wrote for each inequality? They are the same also. So now compare the sequence of the 3 inequalities to the steps we used to solve them in question 2. So question 2, this is the exact same thing as this, other than the symbols between is different. And when we did our first step and added 2 to both sides, we got 3x equals 9. That's what this was. So this is equal to this. Same thing. It's just a simplified version. Then, if I look again, this is the same as this, except a different symbol between. So it makes sense that we get the same answers because those 3 steps are just simplified versions of each other. So what do we notice? They're simplified versions of the original inequality. So graphing, this is kind of the new piece. When we graph, we use a number line. And when the symbols are just greater than and less than, it's an open circle when we graph. If it's less than or equal, greater than or equal, it's going to be a closed circle. So looking at this, I know I have a closed circle. So when we solved it, we would get x being greater than or equal to 3. So at 3, I'm doing a closed circle, and I want all the values greater than numbers go this direction on a number line. So that's how we graph. But now we can check our solution to an inequality by choosing a value that is in your solution set and substituting it into the original inequality. If that substituted value makes the inequality true, then we verified a correct solution. So choose a value from the solution set. So I'm going to take 5. I'm going to use 5, and I'm going to substitute it into the original. 3 times 5 minus 2 greater than or equal to 7. Order of operations, 15 minus 2 greater than or equal to 7. 15 minus 2 is 13. Is 13 greater than or equal to 7? Yes, it is true. So we were able to verify a correct solution. So I know 5 is correct. So if I would have accidentally drawn the arrow the opposite direction, I need 5 to be a solution, so it should be included in my arrow. Let's try one more. We're going to solve the inequality, and then we're going to show our work, and we're going to graph. So the first thing I do is subtract 5 to both sides. 2x less than negative 17 minus 5 is negative 22. Divide both sides by 2. and I get x less than negative 11. So now I'm going to graph it. So I always want to give myself 0. So negative 11 is somewhere down here. I don't need to put every mark in. This is an open circle because it does not include 11. Everything less than negative 11. So all the numbers less than go this direction. So this is the solution set. So now I'm going to check. I'm going to take some number along this path. So negative 12 would be down here. So I'm going to check it. 2 times negative 12 plus 5. And I'm going to see if that is in fact less than negative 17. 2 times negative 12 is negative 24 plus 5. Negative 24 plus 5 is negative 19. Is negative 19 less than negative 17? Yes, it is. So more than likely, I've graphed this correctly.